Hello everyone, it's February the 8th. A late night again, but it's fine. Uh, did some data collection today. Lasted 3 hours. 3 hours under the sun. Man, I have all the protection, but still, it's always data collection day is always tough. Very, very tough. Anyway, so let's see what we have today. What we're gonna do, this is for tomorrow actually. Right, we have K diff pairs in error. Have we done this before? Yeah, we have. 2020. Okay. What is this? Given an array of integers nums and an integer k, return the number of unique k-diff pairs in the array. A k-diff pair is an integer pair where the following are true. So I is smaller than j, and the difference is k. Note that this denotes the absolute value. Okay, so there are two diff pairs. 1, 3, and 3, 5. Although we have two ones in input, we should only return a number of unique pairs. So wait, hold on. So this doesn't really matter, right? Because if you return, it shall be 3, 1. Because if you go I is smaller than j. But I think basically let's just say I and j cannot be the same. It has to be different. So this is 1, and oh, hold on. I was thinking it can be used twice, only once, but no. 3, 1, 3, 5. And this 1, 2, 2, 3, 3, 4, 4, 5, right? And just 1, 1. Okay, so first thing ahead is because it's k difference, right? So we pull a counter on this. Right, we pull a counter on this, and we just say 3, right? Which is plus 2 minus 2. Plus 2, we find 1. Minus 2, we find 1. Boom, done. Now 1 plus 2 minus 2. Well, how do I avoid? Well. Plus 2 minus 2. How do I know? Then this one will become 1, 3. Good question. How do we avoid? One thing we can do is after we've done that, we just remove it. Right? We remove 3 from the list because I've done with this. So I remove it. Now for 1, I only have minus 2, which is minus 1, but we don't have minus 1, and I have plus 2, 3. We don't have 3 anymore, so 1 cannot do, 4 cannot do, 1 again cannot do. That's actually, okay, now we don't delete, we just decrement by 1, right? We just decrement by 1, which means you just cannot use that again. Yeah, it seems like this will work. Okay. Let's handle this. Alright, so we need a counter. Yeah, I was actually thinking about, maybe I need to learn, go back to C++ or go back to, I don't know, Java. Java is easier to handle than C++. But that means a lot of learning curve. Not sure if I want to go down that path. Maybe I should. It'll take time. It'll take time, especially solving problems. We may have to go to the easy problem just to get used to the language. And maybe I can do that. Like I can do, let's say, the regular problem. I use Python, and then I just change to Java to C++. because on the job market, these are still very popular languages. Very, very popular. Actually, I don't even know how to write it. So you guys ask me, write C++ right now. I can't. I can't like from scratch. It will be very tough. But it will be fun. It will be fun. Yeah, something to think about. And then I have to find, okay, what is a counter in C++, right? Something like that. That's actually not too bad an idea. Maybe I should do it. Huh. All right, so res equal to 0, right? And then for we say n encounter, right? Okay, what do? We say if we can just do if I can just say res plus equal to counter n plus k and res plus equal to actually I can do this plus counter n minus k, right? We do this and return res. Really? That's it? I'm not quite sure. I feel like this is a bit too easy. Mind you, it's past 11 o'clock. My brain is not working. Like after 10 o'clock. At 10 o'clock, everything becomes mushy. So there's a high chance that this is not working. For one thing, right? It's plus itself. Now that is the issue. I just see the issue on the last one. But we're gonna run it first, so just kind of see. Yeah, I already know the last one's not gonna work. I need to handle that situation separately. But let's just put everything and then just run it. Too many to unpack because we forgot the K. And they're all wrong. All right. So, and again, this is not working. Okay, so one, I think it's not, right? So it has to be if counter all right, so I'm looking at myself. So counter n has to be minus equal 1 because I'm looking at myself, so I cannot do myself. And then I say if counter n plus k, right? Then we say res plus equal 1. Can I? It has to be 1. If counter n minus k, res plus equal 1. Like this. Alright, so we pass these two, but still fail on this. Result is 2. How? 1 comes in, right? And then minus 1, so 1 has a 1. And plus, I did it twice. So when k is 0, that's a special case. I mean, I just realized there's something I can do. I think I pretty much can do res plus equal to. Actually, I'm not quite sure. I think Python has this. Right? I can say a plus true. No, 1 plus true. I'm not sure how to say a plus true. That's 2, right? So I can say, I just do a boolean on this, right? We do boolean on this and we say if k, which means it's k is not equal to, then res plus equal to counter, boolean it, counter in minus k. So this is a special case to handle k equals 0. Yeah. So I think this shall be it. All right, let's try this. Oh, we got an error. Terrible. Madre mia. Last time I success in one shot. This time is not. 3. What's the solution? Expected 2. The heck? One. Well, that's 1. Right? 2. 2. Nothing. 4. Well, minus 4 only have 1. So 4 plus 2 is 6. 4 minus 2 is 1. 4 minus 3 is 1, but 1 is already I minus equal to 1, so it shouldn't be. And 3 and 0. 3 and 0. Oh, 3 and 0. When I handle 0, I see. If counter n. Yeah, it was my bad. Counter n. Now we just do if counter n plus k is n plus equal to 1. And after that, counter, because I used it, right? But I shouldn't. I use it just for this purpose. I just never minus. Right? I just never minus because I minus if I sorted it. Right? If I sort it, I just never do minus. 10 to the 4th. Yeah, let's sort this. Right? Let's sort this. Therefore, when I add, I never minus, right? I never minus. Minus will be repeating. And if I add, I think I can do the same thing. And I don't need this because I'm not reducing. So it's this, and then rest plus equal to boolean counter n plus k. I always go larger. Yep. So sort is the way to go. All right, let's try this one. There we go. I do have to sort it first. Let's see. Yeah, just pull both and I kind of take a look. So yeah, it's not hard, but I'm very disappointed that I made a mistake. Didn't test it thoroughly. All right, so this is 532. All right, so we use counter to handle the part where we search for the partner of the current number under consideration. An important trick is to sort the numbers and then to sort them and then go from small to large, and only consider n plus k situation. This is This is to avoid what? This is to avoid duplicates. Because if n and n plus k is a pair, there is no need to check n plus k minus k situation. Oh, we'll log in because we sorted it, and I mean, if we don't sort, then we have to. We can do that. If we don't sort, 81, 70. If we don't sort it, we need to figure out a way to handle duplicates. This I didn't sort. And I only plus k. Huh. Well, you don't have the sort. Oh, we have this. What is this? Yeah, I noticed this. And I do plus k. Okay. And oh, I restore it. Hold on, let me think about this. So every one I plus, right? Every one I plus. And what about something then, and I don't do minus? So I only plus k, right? I plus k. So if I plus k, and this one, oh, it doesn't really matter. Sort or not, it doesn't really matter. I just realized it doesn't really matter. Because I will handle every single one. Yeah, I don't know why I sorted. I actually don't think it matters. It's just counter. And I would do plus. It does matter. 3 plus 2, I have it. 1 plus 2, I have it. Now, 3 plus 2, I have it. And then, I see it. Like in this case, I have to sort, but yeah, that actually, the original solution was pretty good. This is not as good. All we need to do is to, because everyone with plus, right? Everyone with plus. But if we remove it, then it has nothing. So everyone, when I consider it, I remove it and I find, and after that, so this is the solution from last time. Last time I did this problem. It is better than the one I had today. It uses backtracking, right? Backtracking idea. And does not require sorting. So just for this, and then counter and plus equal 1. Right? So finish considering and return it to normal. And because everyone only do plus, everyone do plus, so there's no risk of overlapping. Yeah, this is better, and this is all in. I mean, it won't be too much difference in terms of the time running, but it's not different because the total size is quite small, so it will pass about the same time, but it's definitely a much easier solution, in my opinion. 60. Okay, more test cases on this one. All right, so that's that. Like meh. All right, what is this? Wait, have I done this before? No. All right, this is the extra. Find bottom left tree value given the root of binary. Oh, it's all binary tree. Then the leftmost value in the last row of the tree. So that's a 1. That's a 7. Interesting question. Very interesting question. So if we go left first, I need to record its level, right? And then we do this. So we go left, and then wait. It says the leftmost value. So even if this one is the right tree, we'll still return. Yeah, we can actually double check on this. We can check on this by doing this. But we have a tree visualizer. So what we want is 5. Hold on, 3 and 4. No, 5, 6. No, 7, right? Yeah. So if we run this, it shall still return a 7. Yeah, it should return a 7. So yeah, so basically we will want to find is the last row. Well, we can figure out the last row. And if we go left, right, now left, root, right. Can we guarantee? So if we're left, always go left first, then root, and right, go all the way down. Is that guarantee that we'll always visit the leftmost first? Yeah, because we go left first, so we will always visit the left first. And then we just keep a value to record. Every time we hit, if it's a new value, right, if it's a new depth, then it's guaranteed. If we hit a new depth, whenever we hit a new depth, that will be the first new depth we hit, the leftmost we hit. And if we hit a new thing with the same depth, then we don't push into it. But if we hit a new one and we update it, the first time that we hit a new one and we update it. Let's give it a shot. I feel like this shall be right. 513. No. Like, it didn't make any sense. 3. Okay, so my idea is to go left and then left root right. Right, I'll go left root right. Seems like it should be fine. So we need to keep track of the level, right? And so val and height. V and H. How about that? V and H. What's V? That's a value. Doesn't matter. Some values it doesn't contain. Value. This doesn't matter. Doesn't matter. I only put a 0. Height. Let's put -1. Right. And then we say dfs. We need a node and we need a height. And this thing we do not return anything, so we don't have to. So if we go node, so we need to identify the root, and the leaf. So if node, if not node.left and not node.right. So this is identifying, right? So we say identify the leaf. Once we do that, the height is the current height. And we say if the height is larger than h, then v will equal to node.value. Right? Which I realize we can put this one here as well. Right? And this, we update this. And return. Right? Otherwise, ew. Otherwise, we just say if node.left, dfs, left, I plus 1, if node.right, then dfs, right. That's actually not a left root, right? It's a root. We visit it first. Actually, no. We do these. We go left. We go right. It's actually fine. It's actually fine. Okay, and then we run dfs root height is 0 and return v. We can run a test case. Okay, so this is one of our test case. When we add, right? I run this. Syntax error. Oh, there's no F. My bad. Let's see that. Ew, that's not right. 0, 0, 0. If not node.left and height is larger than h. Oh, of course, this has to be self. We're updating it. Syntax. Alright, that's still not right. We have, the first one we have 3. How? I go left first, right? So this is left. Oh, I didn't. Oh my god. Alright. It's not working. Let's just say left leaf. Left leaf is gonna be 0 minus 1. Doesn't matter. And then we're gonna update both. Left leaf 0 equals this. Left leaf 1 shall equal to height. Then return. And I'll do this. And we're gonna return left. leaf 1. H is not, of course H is not, because this has to be left leaf 1. That's still not right. That's 3. What the hell? Well, it's fine, we'll update the 3, but then I go to 5. Oh, that's 3 levels. My God, so many errors. See, that's what I was talking about, right? That's what I was talking about. It's very bad. And then we can run the edge case of a single value. Let's see how it defines. I should have 2 edge case to run. I have another one. We have another one. Yeah, but I kind of too lazy to do. I'll just see. This one's fine. So let's try it. Yeah. Well, not a difficult problem. All we need to do is DFS, right? DFS while keeping track of the height. If as long as we DFS with left branch, right? Left branch first. The very first, the very first node encountered on a lower level must be the leftmost leaf. And I just realized this one will be very easy to do in BFS. Why don't you do BFS? Right? That'll be quite straightforward to do in BFS, I think. Let's try BFS. So what BFS need is, just record the first one. Okay. So res equals, doesn't matter what it equals to. Q equals to root, right? Q is this, and then we say, Q temp equals this for node in Q. Temp is this, and then res equals Q 0.val. And say if node left. Yeah, we'll go left first, right? If node left, temp.append left, node left, and then if node right, temp.append right. And Q equals and return res. Okay. Wow, I'm so tired now. Very sleepy. We're going to run this. Yeah. I think BFS is actually easier. Look at that. It's easier to implement and understand than BFS and then DFS. And then we run at 41 milliseconds, 83% ranking. Okay, just glancing through the discussion. Left to right, BFS. Is this a node? Oh, it's going right to left. Oh yeah, pretty smart. Yep. So we don't have to do this, right? But overall, it's the same thing. The same a few lines. All right, that will be it for today. I did pretty well. I mean, the problems are easy, so got lucky. 2 days in a row. I'll see you guys tomorrow. Adios.